We're just outside this unassuming building in Berkeley, California, where a team of 50 people is working on one of the biggest problems for climate change. Founded by 3 Stanford graduates, 12 is trying to take captured carbon and repurpose it so that it can re-enter the supply chain and become the building block for everything from shoes to your next fancy car. We're going to speak with Kendra Kuhl, one of the 3 co-founders and the Chief Technology Officer, and she's going to give us a tour of the lab and just answer our questions about how feasible is this. Could you explain just in the most basic sense, like what is it that you've done and what are you aiming to do? Because when I read it on paper, it sounds just like crazy ambitious and like, you know, perhaps like too pie in the sky. It sounds extremely difficult.
So the core technology of the company is a catalyst that allows us to break apart carbon dioxide molecule and reform the carbon and oxygen and hydrogen from water into new compounds. So we can take carbon dioxide, from anywhere. Instead of that carbon dioxide being emitted to the sky, transform it back into, essential products, or we can, coupled to direct air capture, suck that carbon out of the air and then make it into something useful again.
The idea of reusing the carbon we've already extracted is a key part of the circular economy, a grand hope that society can re-engineer the way goods are designed, manufactured, and recycled. The concept is being embraced by some of the world's largest companies, including Apple, which says that it hopes to make all of its products using recycled materials, and Ford, which is already building 3D printed car components out of what it calls waste powder. As the late architect Buckminster Fuller once said, "Pollution is nothing but the resources we are not harvesting. We allow them to disperse because we've been ignorant of their value." So if it's such an important idea, why aren't there hundreds of startups trying to do this?
I think it is hard. The other inputs are renewable electricity and water. And so we are reliant on the growing impact of renewable electricity on kind of decarbonizing our grid in order to really transform the CO2 emissions.
Earlier this month, you had your first Series A funding round. I think you raised $57 million. Where are you now in terms of like the proven technology?
So today in our lab, we have a system that does kilograms per day transformation of carbon dioxide. We want to go up to tons per day.
Okay, so show me what we have here, Kendra.
Yeah, this is the system that we use to deposit that catalyst and make a layer onto a polymer electrolyte membrane. And then that's what goes into our system to do the carbon dioxide transformation.
So sorry, is this an additive manufacturing type thing?
Yeah, similar, but super small scale. The layer that we're depositing is much thinner.
How thin? Like, are we talking about like hair length thin?
I can't tell you exactly how thin, because that's part of our core technology, but thin.
This does look a lot like a 3D printer in terms of how it's...
Yeah, we have a solution containing, catalyst, additives, and then just a solvent that those other components are dispersed in. And then that's fed into one of these nozzles, and then forced down by an airstream onto the substrate, and the solvent dries and it leaves behind the solids. But you can already see, we can coat really large areas.
Right, and so it's totally unclear to me as to what happens next. So once you've got this coating, then what?
Ultimately, we can put this into, a cell that's, as big as this deposition area.
At scale, is this machine just much, much larger, or do you have many of these machines?
I think it's a different layout, so more of a roll-to-roll or conveyor belt type of process, more continuous production. This is a relatively small system, to be honest. You can make this as big as your whole room or your whole facility. I think technology gives us options, and so we have choices, and so we can choose to do something about climate change because we have technology like this.
Right. So we're not doomed. Or we might be doomed. But you hope we're not doomed.
Yeah, I don't think we're doomed. I think some of the beauty of this solution is that it doesn't require you to be a believer in, carbon dioxide being an ill or not and causing climate change. We aim to be cost competitive at scale, and so there won't be an economic cost to, using these CO2 made materials. The other thing we should look at is the actual prototype. This can transform kilograms per day of carbon dioxide.
You do have a prototype doing that?
Yeah.
Okay.
One of the advantages of these types of systems is that they are kind of like kind of just run on their own. Like you turn it on and it
It
goes.
is like a dishwasher.
It's like a dishwasher, literally. You don't have to be tweaking things or tending things.
Okay.
Like every 3 months you have to replace a filter, but it's not like rocket science,
Anyone could
right? I think anyone could replace the filter. So yeah, the next scale from here would be kind of a couple shipping containers worth of volume, but probably not in a shipping container, probably a skid. And it would look, like a scaled up version of this, essentially, but it's a little bit like a chemicals plant, but quiet, operating at ambient temperature, and no kind of smells or fumes or anything that you might like associate with a typical chemicals plant.
Right. This almost looks like a caricature of like
Right,
an actual thing.
Mad scientist lab
yeah,
or something, right?
What are we looking at here, Kendra?
Yeah, so to develop our catalyst that transforms carbon dioxide, we've done a lot of testing and optimization. The stand is designed to allow us to control, the input of carbon dioxide, water, electricity, and then measure what's the energy utilization that we're getting out of the cell, what's the temperature, what's kind of the optimal operating conditions.
So are you sort of tweaking the inputs, running the same process and seeing what the outputs are?
Yeah, so we're iterating, as rapidly as possible on, the conditions, the materials, and then also the cell hardware to really achieve the performance that we're looking for. This is an artificial tree.
Okay. So describe what an artificial tree is, because the concept, mind-boggling.
Right. I think if a tree takes carbon dioxide from the air, water from the ground, and sunlight as the source of energy, and it makes carbon dioxide into sugar. Our devices are similar because they take, carbon dioxide and water, from the inputs that we're feeding to them, plus energy in the form of electricity, and then can transform that carbon dioxide into not sugar, but other kind of intermediate products.
So this might be a silly question, but like decades from now, if like the Brazilian rainforest is like continuing to be reduced at the rate it's been cut the last 30 years, I mean, I don't want to in any way say like we can make up for that and that's okay, but is it just like more and more of these will end up doing the work? Like, are we having more and more artificial trees in the absence of real ones?
I mean, the energy has to come from somewhere, so the energy here can come from the sun when we couple it to solar panels. But I would say, trees provide a lot more benefits than just CO2 mitigation, right? I mean, it's a whole ecosystem. This is obviously a piece of metal, so I would not trade a tree.
Okay, you'd prefer real trees.
I'd prefer, we keep all the real trees and have these systems in addition to that.
Yeah.